question is find the hole depth and working depth.
Yep.
And the pitch.
Well, this is two separate problems. So for the first one up here, we're asked to find the pitch. Given that we have the pitch diameter of 0.7273 and we have 16 teeth. So in our packet, if we flip back, 247 and 248 has a list of formulas. It's a table. So we are looking for the pitch. So we're going to look for, in that first column, we're going to look for the pitch, which is actually on page 247, and it's the first thing that's given. And the formula that we're given there is that the pitch, there's actually two different formulas. One of them uses the circular pitch, which we don't have. The other one used the number of teeth and the diameter. So the formula that's given there is the pitch is number of teeth divided by the pitch diameter. So for this one, we're going to do 16 teeth divided by 0.7273. Gives us a pitch of 21.9999. Since we're going to assume the 0.7273 is rounded off, chances are that's 0.727272. The 21.99 we're going to round to 22. So it's a pitch of 22. What that is saying is, on average, there's 22 teeth for every inch of diameter. Remember, that's diameter. 1 inch of diameter is pi, or 3.14 inches of circumference. So that's 22 teeth for every 3.14 inches on the circumference of that circle, of that gear. Now for the next one, we're asked to find the hole depth given a pitch of 3.14. So we're going to look up in the table the hole depth. This is on page 248. We've got hole depth, WD. Be careful because it's really easy to confuse that with working depth, which is W sub D. We are given the pitch of 3.1 or 3.4. We do have a formula there that just involves the pitch. The working depth is 2.157 divided by the pitch. So we're just going to plug that in. 2.157 divided by 3.4. Which gives us 0.6344. So the hole depth, I should say, the hole depth, if we're looking at a gear, pretend that looks round.
Which one did we just solve for?
We just found the hole depth. No, the hole depth. The hole depth is the top one. I haven't done the bottom one yet. This one we haven't got to yet. So the hole depth is from the outside of the tooth to the inside of the tooth. Remember, the working depth is when we have another gear that's meshing with it. It's how far the tooth of the next gear penetrates into that gear. That would be the working depth. And let's see if we can find that from what we're given. Well, if we go down to working depth, there's a formula there. W sub D is working depth. When you see that letter that's just smaller like that and down below, that the term there is sub or subscript D. So that is 2.000 divided by P. So we're going to plug in our pitch of 3.4. Which is going to give us 0.5882 inches. With that information, we should be able to find the addendum. The addendum, remember, is going to be the difference between the hole depth and the working depth. Now, I didn't ask for that here.
Why are you, okay.
Now the addendum on the chart, they use the pitch to find the addendum because generally you don't know the hole depth and the working depth. That's one of the reasons why you're finding the addendum is you measure the hole depth of the tooth and then you can use calculate the addendum from the pitch and find it. The addendum is the distance from, well, the clearance is going to be easier to find here. The clearance is the distance from this tooth penetrating to the inner diameter of the next gear. So you can find the clearance just by subtracting them. The addendum would be a little bit more complicated. Once you have the clearance, you could find the pitch and go back and find the addendum. So what we're going to look at today, we're going to look at a couple of things. One is, what if I give you, oh, I'm trying to find one here that doesn't, let's let the packet do the work for us. What if I ask for the hole depth but I give you the number of teeth is 10 and the pitch diameter is 2.5. So I need the hole depth. Well, I look for hole depth. I'm going to look up hole depth again in my chart. On page 248, I look up hole depth. Hole depth, WD, well, is, oops, make sure I get my numbers right. Hole depth is 2.157 divided by P, which is the pitch. Do I have the pitch? No, I don't. I have pitch diameter and I have number of teeth, so I don't have the information I need for that formula. The next formula for hole depth, WD is 0.6866 times the circular pitch. Do I have the circular pitch? No, I don't. So I don't have the information I need for that formula. Yeah, that's what I'm getting to. But I want to go through the formulas and make sure there isn't one that's easier to do than we do in one step. And the final formula, working depth is equal to addendum plus doaddendum. We don't have either of those, so that one is definitely not usable. So now we've got to look back through these formulas and see if we can find one of these values. In fact, we can find either the pitch or the circular pitch. We're going to go ahead and find the pitch since it's a little simpler. So we're going to come back to this formula here. If I knew the pitch, I could find the working depth from that formula. Well, given the number of teeth and the pitch diameter, I can find the pitch. The pitch is equal to the number of teeth divided by the pitch diameter. So I'm going to go ahead and put in 10 teeth divided by 2.5. Gives me a pitch of 4. And now that I have a pitch of 4, I can come back to this formula to find my working depth. My working depth is 2.157 divided by the pitch, which is 4, which is going to be 0.53925. We're going to 0.5393 inches is what our working depth is going to be. Or, sorry, that working depth, this is hole depth. So sometimes you're going to have to, none of the formulas that are given for that item are going to be usable with the information we're given. So sometimes you have to use the information given to find other information that'll be useful in our formula. Other times, what we're looking for may not be the formula we need. For example, we might be asked, find circular pitch. Given the working depth is 0.45 inches. So we find circular pitch on our table here. That's on page 247. But our formulas for circular pitch, PC is either 3.1416, which is just pi, times the pitch diameter over the number of teeth. Don't have that information. Or the other one is the circular pitch is equal to 3.1416 over P, which is just the pitch. So what we need to do here is look to see, can we find any of the things that we need here? Can we find the pitch from the working depth? Well, we look at the pitch, and there's no formula for pitch that involves working depth. So we can't find P from the working depth. We can't find the pitch from the working depth. Over here, can we find the diameter or the number of teeth? Or the diameter and the number of teeth from the working depth? Well, solving for two unknowns from one known is really kind of tough to do. So that's most likely going to be a no. So what we have to do then is work backwards. Rather than looking up the formula for what we're trying to find, let's look up the formula for what we're given. Let's look up the formula for working depth. So on page 248, we've got working depth. Or that's W sub D. Working depth is 0.157 over the pitch. Well, we're looking for the circular pitch, not the regular pitch. So that formula doesn't do it. We have working depth equals 0.63, come on, 0.6366 times PC is the circular pitch. That's the formula you want. So instead of plugging the information and just solving a formula, we're going to have to work backwards and solve an equation here. So we put the 0.45 in for the working depth. And now we're going to have to solve this for the circular pitch. So we're going to solve that by dividing by 0.6366. So the circular pitch gives us 0.7069. This is our circular pitch. Okay, the last thing we want to talk about then from this packet is we want to look at the metric module system. When we talked about pitch, remember pitch was number of teeth divided by diameter, which gave us the number of teeth per inch of circumference. Well, it's per inch of diameter, but multiplied by pi, it would give you the number of teeth per inch of circumference. The problem with that, I mean, it's worked well for standard gear, standard measurement, but it would make more sense to use something that tells us the actual distance between teeth. And so the module system, a module M, which is called a module, the module of a gear is the diameter, of course, in millimeters divided by the number of teeth. And what this gives is, rather than giving the number of teeth per unit of circumference, this gives the distance between teeth. Now again, we're using the diameter instead of the circumference here, so the module itself is not the actual distance between teeth. The PC, the circular pitch, gives us that calculation. That is the module divided by 0.3183. I do not know why, but this packet seems like deathly afraid of using pi. The 0.3183, if I remember right, yeah, it's just 1 over pi, is all it is. But for some reason, they're deathly afraid of using pi. And I don't know why they even put it as M over 0.3183. This really is just pi times the module. Gives you the circular pitch on a metric gear. So I'm not sure why the packet chose to do it that way. It seems a little backwards to me. But it does. So let's say we have a gear that has a diameter, now a pitch diameter, of course, is just D, of 48 millimeters. And it has 16 teeth. So the module for this gear is 48 millimeters over 16 teeth, which gives us a module of 3 millimeters per tooth. So it'd be called a module of 3. We don't use the label on the module. We know what the label is supposed to be. So this is a module of 3. Now, it's like we said yesterday. Why this is really important is for this to mesh with other gears, they must have the exact same module. If another gear has a module of 3.2, they may appear to mesh together, but they get moving at high speeds. They're either going to bind and lock up, or they're going to bust out teeth. So they must be exactly the same. Just like we ran into with our pitch yesterday in that last table, there are the last several ones here from the addendum down to the clearance that have the stars by them. Again, those are only working with gears that meet certain classifications. They have certain clearances. So those are not general formulas given there. They're for special type. They're the most common type of gear, but those are only applying to certain special types of gears. So let's take a look. Let's say I give you, let's say you are given that the module is 4.5. I want you to find the addendum. So in that table, we're on page 250 is the table for the module system. What are we going to look up? In that left column where it says term, what's the term we're going to look up? Well, in this problem, we only have two things given, the module and the addendum. The one we're going to look up in that column is the one we're trying to find. Which one are we trying to find here? The addendum. So we're going to go to that left-hand column of that table, and we're going to look for the word addendum. And you find it about halfway down the table. Addendum, A equals what? Yeah, A equals M. A equals the module. So the module, this is 4.5. The addendum is 4.5 millimeters. That's another reason why they use the module system this way, is the addendum and the module end up being equivalent. Let's say that I give you we have a module of 1.4, and I want you to find the whole depth for a gear for clearance that's equal to 0.1667 times M, times the module. I'll go over what this means in just a second, but what are we looking for in the left column of that table now? What are we trying to find here? The whole depth. So in the left column of that table, we're going to go down until we find whole depth. So we find the whole depth. We look across. WD has two different formulas there. One has one asterisk, one has two asterisks. If we look down at the bottom, one asterisk means when clearance is 0.157 times the module. That should ring a bell with what I said here. I said clearance is 0.1667 times the module. The 2 asterisk means when clearance is 0.1667 times the module. So that means which formula do we need? The second one, the one with 2 asterisks. The working depth, or the hole depth, sorry, is 2.167 times M. So 2.167 times 1.4, which is 3.034 is our working depth. So what if I give you the tooth thickness is 2.83, and I ask you to find the module. So I'm asked to find the module, so on the left side of the table, I find module. Module is actually the top one there on the left side of the table. The problem is the formulas I have for module is module equals diameter, the pitch diameter over the number of teeth. I don't have either of those pieces of information. I have the tooth thickness. So that didn't work. So my second option then is to look up what it is that I'm given. So I look up the tooth thickness, which is the bottom one down here. The formula I'm given for tooth thickness is T is 1.5708 times the module. So here's one where we're going to have to work backwards. We're going to use the formula for what we're given and work backwards to what we're trying to find. So we're going to put in 2.83 equals 1.5708 times M. So 1.5708. So divide out. So 2.83 divided by 1.5708. Does 1.5708 ring a bell to anybody? There you go. It's half a pi. So we get that M is 1.802 here. To me, it would make more sense to put pi times the module divided by 2, or pi divided by 2 times the module, but they want to use all these decimals in here for some reason. Okay, any questions? Down here, I had this equation, right? I knew the module, or I didn't know the module. I'm looking for the module, but I know the tooth thickness. I put 2.83 in here for the tooth thickness. Then I solved it for M by dividing by this. I just divided that out to get the 1.802. You know, I want you guys to really spend some time on these. If you didn't get through all the ones from yesterday, I want you to go back and work on those, because the point here is not to deal with spur gears. I really don't care about spur gears, and I'm sure you guys don't care that much about spur gears. But one of the biggest skills in your trade, well, I'm sure you hear it preached a lot in the shop, the machinery handbook, is being able to look up stuff in that handbook and find the formulas and use it. And of course, what we just went through here, and I know I kind of exaggerated a little bit, but the first thing you're going to look up in that machinery handbook is what you're trying to find. You look up what you're trying to find, then you got to check to see from the formula that you're given for that, do you have all the pieces of information that you need to put into that formula? And if you don't, well then you can't just stop there. You've got to figure out, oh, how do I make this work? So then you look up the formula for one of the things that you're given. and see if from that, if there's only one piece missing. The key is for any of these formulas, you've got to find a formula where you know everything. In other words, you have all the information except for one. Whether that piece of information, preferably the piece of information that's missing is this number here that's in the front of the formula, so you just plug in the other numbers and do your order of operations. But sometimes it's not that easy. As we saw here, sometimes you have to look up the formula for one of the givens, and then what you're looking for is actually an item in the formula, so you got to solve the formula for that item. Other times, as we saw in some of our other examples, you don't have one of these numbers here that you need, and none of the other formulas work, so you actually have to figure out, can I calculate that missing piece from the other information I have? That is a vital skill for you guys to be able to do using the machinery handbook and looking up formulas. So if there's nothing else that you remember from the 2 semesters of math here, that is a skill that you have to be able to do, is to be able to look up those formulas and figure out which formula is going to work for the information you have and what you're trying to find. So just a little bit of review from yesterday. Remember, yesterday you were assigned page 252, I believe. Actually starting on page 251 through 253. We had assigned 1 through 53 the odds. Today, we're going to start on page 254, and I'm going to have you work on 55 through 63 the odds. And again, I realize I'm giving you over 15 minutes here to work on homework, but I want to make sure you guys do a significant number of these problems. So I'll give you guys the last almost 18 minutes here to get started on those. See how they go. So make sure you're working through them. We are officially done with Unit 2. This is just a 3-day unit, which means Monday is Unit 2 test. This test is only worth 40 points instead of 100, just so you know. So it's a smaller one, but it's still an important one.